in this unit on stats was all about where is the middle, and lesson 2 was all about how we measure how spread out a data set is. And the words that we used were, for the middle was mean, median, and mode. And for measuring how spread out a data set is, we use the words range, interquartile range, or IQR, and the standard deviation. Now, in order to find the interquartile range, we first had to find things called quartiles, so Q1, Q2, and Q3. And in order to find those things, we often had to find the position of Q1, the position of Q2, the position of Q3. And to do that, we always use these formulas. Now, the question for you is, what is the mystery n? What is the mystery n in the position formulas? Who feels like they know what the mystery n is? You can pop it in the chat. You can raise your hand. It's the number of terms or the number of items in the data set. Perfect. Yes. So if, for example, n was 19, then the position of Q1 would be 19 plus 1 times a quarter. So it would be the 5th position. This one over here would be 19 plus 1 is 20. That would be the 10th position. And then this one here would be the 15th position. And then we could use that to help us work out this. And then once we'd worked out that, the interquartile range is just Q3 minus Q1. And we also spoke about the fact that this part here is the middle 50% of the data. Okay. Give me a thumbs up if that all sounds familiar. Give me a thumbs down if that feels a bit, or give me a question if that, if you're unsure of something. All right. Now, what is lesson 3 going to be all about? Well, it's going to be a little bit at the beginning about standard deviation. I'm going to just go over that quickly. And then we are going to talk about something called the 5-number summary. And then we're going to talk about the graph of the 5-number summary, which is called the box and whisker plot. So we're basically going to be working on summarizing data and graphs that summarize data, and that graph is the box and whisker plot. But before that, I just want to check that you all know how to use your calculators properly. And I found this fantastic video that I've put on the Google Classroom. I've updated our Google Classroom, but I just want to watch it quickly with you. And I want you to have your calculator ready to go so that we can all be certain we know how to find the standard deviation. So give me a heart in the emoticons when you've got your calculator ready. Give me a heart when you've got your calculator ready. Okay, so this is going to show you, and I will stop the video as I go, but I want you to play along at home as we do this. So let's see.
Of course, I need to go to stat.
Okay, so what we're going to do in this thing is we're going to go mode, and then we're going to choose stat mode to start with. So let me make sure this fills most of the screen.
Statistic mode first. So what I do, I go setup, and then I go option 2.
Okay, so number 2 is for stat mode. Now look at the data that he has above here, which he's going to input later on.
Statistic mode, and
then he's going to select 1 for variance.
Option 1. So and
then we have a data table. Now we are going to input all the data above here by going 9 equals, 3 equals, 5 equals, and so on.
If your calculator has a frequency column, so it doesn't affect anything, so just leave as it is, okay? So just ignore that column. So just put the value in, okay? So let's go 9 equal, 3 equal, 5 equals, 6 equal, and then we have 8 equals, 7 equals, 6 equals, 7 equal, and then we have 11 equal, 7 equal, 8 equal. So that's it. Now what we do.
Okay, so once you've inputted your data set, you're then going to hit AC to clear. So you're going to hit the AC button here, and then Shift, and then 1. So let's watch this.
Just clear the screen first. So we just go Shift, Option 1, and then,
Shift, Option 1, and then we are going to choose 4 again for variance.
The variable, so which is option 4.
Variance variables.
And we need to.
Okay, now for those who were here last time, what number is the standard deviation going to be? There's a couple of numbers on the screen and different symbols. Which one should we choose for the standard deviation? Which one should we choose? I'm looking at the chat. I'm waiting for some answers from the students of the room. What number would the standard deviation be on the calculator here? Let's have a look. Elobukile, Siamtanda. Who has some ideas? Ntakeni, Nokabonga. What number do you think, even if you get it wrong, I want to see you participate. What number do you think is the standard deviation on the calculator here? Maybe there's a bit of a delay with the internet, but I want to see what you guys think it is. Oh, you'll calculate the difference, Yamtanda. Okay. All right. It's not 4, actually. It's 3. So number 3 is the population standard deviation. Number 4 is the sample one, and we don't want to use number 4. We use number 3, which is the sigma symbol for the standard deviation. So just to put that into perspective, it's 3.
Choose option 3 because it is a population. So now we just choose 3 and don't forget.
Okay, then after that, you're going to hit equals. So when you hit equals, what do you guys get? I want to know what people get in their calculator. So hit the 3, and what answer do you get? I think everyone at home, I'm seeing positive answers. Let's see.
We need to put equal.
And you get 2. So 2 is the correct answer. So if you need to figure out how to work out the standard deviation, watch this little clip. There's something else I want to show you at this point. If you had chosen number 2, what would number 2 have given you? What would number 2 have given you? If instead of choosing 3, which is a standard deviation, what is number 2 going to give you for this data set? Okay, number 2 is the mean, or X bar is the mean. And so you can also get the data set like that. All right, so everyone, that is how we find the standard deviation. And we practiced that in the last lesson, but I just wanted to start with a bit of a review of that. The other new thing I want to talk about today is something called a percentile. So percentile is somewhat similar to a quartile, although it's slightly different in other ways. Imagine you rank everybody in your class from smallest to biggest. Then if you go 80% of the way through the data, the person who is there is the 80th percentile. And that's because 80% of the data is below them, and there's 20% of the population above them. So how would we find the 80th percentile for this data set that I used in the last lesson? Well, first, I need to calculate the position of the 80th percentile. And the symbol we use for the 80th percentile is just P80. Now, the formula for the position of the 80th percentile is just 80 over 100 times n plus 1. Now, this means we need the number of items in our data set. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. There's 11 and 11. So n is 22. I want you to put this in your calculator and tell me what number do you get for the position of the 80th percentile. What number do you get for the position of the 80th percentile? And is it a decimal? So Annalena has got 18.4. Did anybody else get 18.4? Can we have a supporting answer? Siam Tanda is with you. Okay, now, here is the thing that's a little bit, not so weird, but a bit different about percentiles. We don't average out percentiles between the two nearest values. We round it off. So if I round off 18.4 to the nearest whole number, what am I going to get? What is 18.4 rounded off? It's just going to be the 18th position. So if you want to find the 80th percentile, you need to go to the 18th position in this list. So if this gets you to 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, what is going to be the value of the thing in the 18th position, which is the 80th percentile? So that gets you to 11. What is P80 going to be? So I was at 11, then I get to 12, 13, 14, 15, 16, 17, 18, and the value of the 80th percentile is just going to be 27. Okay? So we know that P80 is here, and we can see 80% of the data is below and 20% approximately is above. Okay, using the same idea, I want you to find me the value of the 60th percentile. I will help you a little bit by giving you this formula and reminding you need to round off when you're finding the position of a percentile, but I would like you to try and find me the 60th percentile. What is the 60th percentile? What's the value of the 60th percentile? But you first find the position. So we know that this is 22. So we go 60 over 100, or 0.6 times 23, and I get 13.8. But remember, we need to round off. So this is the 14th position. So what is the value of P60 going to be? What is the value of P60 going to be? Well, I'm going to count, and I remember halfway is 11. So if halfway is 11, then that's 12, 13, 14. Well, the 60th percentile is going to be the value 24. Yeah, and Kilabuhile agrees, and so does Nakabonga, and so does Siamtanda. Okay, I think you've understood this. Give me a score out of 10 for how well you understand how well percentiles work. You basically just use the position formula like with quartiles, except for percentiles, you round off for the position, and then you go and count, and that's it. So give me a score out of 10 for how well you understand percentiles. Okay. Well, we can do one more if you'd like. I can see maybe one more would go well. So why don't you find me the value of the 20th percentile? What is the value of P20? And I'll let you work that out by yourself. What is the value of P20 going to be? You know you have to do the position calculation, but I'll let you go by yourself. What is the value of the 20th percentile going to be? So I get 4.6, but then that gets rounded off to the 5th position. And the 5th position, 1, 2, 3, 4, 5. So P20 is going to be 12. It's going to be 12. All right, everyone, I think we are ready to move on from that. Okay, so what about the next part of today? Well, the next part of today's lesson is all about something called the 5-number summary and the box and whisker plot. So if we look at what is in the 5-number summary, we have the minimum value and we have the maximum value. And then we have the lower quartile, we have the upper quartile. These are called Q1 and Q3. And then we have the median, which is called Q2. So you'll often see people use for the lower quartile Q1, for the median Q2, for the upper quartile Q3, and then min, and then max. Now to show this is called the 5-number summary. And these are important numbers that summarize a data set for us for easy comparison. But in order to make comparison really easy, we use a graph called the box and whisker plot. And all we do is we actually have a number line beneath the box and whisker plot. And the maximum value is basically at the end of the one whisker. The lowest value is at the end of the other whisker. And then there's a box which basically goes from Q1 to Q3. So the box goes from Q1 to Q3. And then in the middle of the box, there's a line which is going to be the value Q2. And then these two whiskers go up to the max value and down to the min value. So I'm going to show you how this works with an example. And then after our break, you're going to do it for me. So let us go to this data set over here, and I'm going to get rid of the number line because we'll use that later. So the very first parts of a 5-number summary are super simple because the minimum value would be 503. The maximum value is 526. Really not hard. Now we need Q1, Q2, and Q3. But in order to do that, I need to find the position of Q1, the position of Q2, and the position of Q3. So what I want you to do for me, I'll call this A, B, and C. find me the position of each of these quartiles. And after we found the position, we can work out the values. Okay, over to you guys and girls. There's one number that could be really important that you can maybe put in the chat, but help me find the position of the quartiles first. Let's count what n is. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. N is 15. Okay. So for Q1, the position is going to be a quarter times n plus 1, but n plus 1 is 16, so it's the fourth position. And for Q2, it's going to be 2 over 4 over half times 16, which is the 8th position. And for this one, it's going to be the 12th position. So now we want to know what is the value of each of these quartiles. What is the value of each of these quartiles? Well, the fourth position will be here. So this will be 507. What about Q2 and Q3? What's that going to be? So the 8th position, 4, 5, 6, 7, 8. So that's going to be Q2 and Q3, 9, 10, 11, 12. Wait, 9, 10, 11, 12 is going to be here. So Q2 is 510 and Q3 is 515. What is the interquartile range going to be? What is the interquartile range going to be for this data set? Can you remember what the interquartile range is? It's Q3 minus Q1. So if I take 515 and subtract 507, I will get 8. So that is the interquartile range. All right, so what is this? How does this connect to the box and whisker graph? So I'm going to write down the whole 5-number summary just so we have it in one place. So it would be 507 for min. Then it would be, sorry, not 507, 503. So 503, then 507, then 510, then 515, and then 526. So those are all the numbers in the 5-number summary. Now, this needs to go onto a graph that I'm going to show you how to draw. So first of all, you need a number line. Now, I've got one here to make life easier, but if you don't have, you can just draw one where you use the smallest value and the biggest value to guide you. And you don't need to go up. You can go up in 2s or 5s on your scale. You don't have to go in a perfect amount. So what I like to do is I go to 507, which is Q1 first, and I go this is where my box starts. So there's going to be one part of the box here, and the box will end at 515. And then I construct my box. So there's the box for the box and whisker. So I've done this and that. Inside the box is a median. And so that would be there. And then on this side, it goes all the way up to 526, because that's the max value. And then on this side, it goes all the way down to 503. Now, there's something quite interesting about this data set, because remember, if I look at this box and whisker plot, the top 50% is up here. That's the top 50% of data. And this is the bottom 50% of data, which is down here. What do you notice about the difference between the top 50% and the bottom 50% of data? Can anyone notice anything here? What stands out to you? It's like it stands out more in this graph than it does in the actual numbers. Anybody want to volunteer any ideas? So what stays with me is that the top 50% of the data looks much more spread out. It's like it's much more spread out, whereas the bottom 50% of data is more closely compacted together. And I just want you to be aware of that, because we're going to talk more about that in the next lesson. Okay. So that is a box and whisker plot. Give me a score out of 10 for how well you think you could do a box and whisker plot. I want to see how you feel about, because you're going to do one by yourself after the break. I want to see how you're feeling. Do you feel like you could do it? Give yourself a score out of 10. Okay, good. That's looking positive. So what we now need is a break, because our brains are getting tired. And you know what my prescription is for a brain that's tired? It's oxygen and blood flow. So we are going to do 3 deep breaths, and then we are going to do 15 jumping jacks. I'm even going to take my jacket off because I'm going to get a bit warm. So make sure that the area around you is clear so you don't whack anything when you jump. Make sure you're standing up. If you are lying down, make sure your body needs to take a moment for itself. Okay, 3 deep breaths. Breathe in. Breathe in. One more time. Okay, so some oxygen is in my body. My brain is happy. And I'm going to now do 15 jumping jacks or star jumps. This is what it looks like. And get ready in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Whew. Okay. I want you to hit the emoticon for the heart if your heart is pumping like mine. Ooh, I am definitely, I get cold the moment I take my jacket off. Ooh. Ooh. Okay. Let's do this. Okay. Second part of today is for you to draw a box and whisker plot yourself. So we're going to look at this data set here. And this data set says the following. It says there are 26 grade 10 learners and their heights have been measured. They've been split into two categories. There's girls and there's boys. And so each of these categories will have an N of 13. So there's 13 girls and there's 13 boys. It says, find the 5-number summary and the interquartile range for boys and girls. So I'll say G for girls up here, and then I'll put B for boys down here. I want you to find me the 5-number summary for the boys and girls data set. So I'm going to let you do that now. You can put them in the chat as you work them out. I will remind you what they are. But remember, you have to do it for both boys and for girls. And you may have to use some position formulas to help you. But I would like you to do that by yourself and just put the answers in the chat as you get them. Okay, over to you, everyone. I'm also just going to get some more water. Now remember, with the quartiles, you do not round off. You average between the two nearest values. So when you work out what Q1 is, what Q2 and Q3 is, because that one's a perfect, it falls on the value. But those two, you're going to have to average out between the two nearest. What are you getting for Q1, Q2, and Q3 for girls? You can pop it in the chat when you are sure. Okay, what are we getting for that? So I get 1, 2, 3. Okay, so Q1 is halfway between there. So does anybody get 154 for Q1? Give me a thumbs up if you get 154 for Q1. Then for seventh position, 1, 2, 3, 4, 5, 6, 7. So that is Q2 is 160. What are you guys and girls getting for Q3 for girls? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it has to be between, so it would be 165. What is your interquartile range going to be for girls? What is your interquartile range going to be for girls? Who can work that out from the chat? Can you remember what the interquartile range is? Just pop it in the chat. So Q3, 165 minus 154. Kilobukilia, I agree. Interquartile range is 11. Okay, now it says summary and interquartile range for boys and girls. Now I will help you with min and max here because we want to speed it up a bit. So the min and max are 180, but I need you now to find me Q1, Q2, and Q3 for the boys. So we've got our 5-number summary for girls, but in order to draw the box and whisker plot, in order to draw 2 of them, I need the stats for the boys. So that's our next job. Oh, but you know what? We can use, because they're the same, its position will be exactly the same. So the position of Q1 will be 3.5. The position of Q2 will be the 7th position, because there's exactly the same number of items in the set of boys and the set of girls. It's both 13. So the good news is the positions will be the same. What are the values of Q1, Q2, and Q3 going to be for boys? I'll give you a bit of time. Oh, Amelia also got 11. Fantastic. What are you going to get for Q1 for boys? 3.5, or it's between the 3rd and the 4th. So it must be over here, which I get is 154. What about Q2 and Q3? So I can kind of see it because they're laid out exactly the same. That's 160. And then Q3, so that is 10.5. So 7, 8, 9, 10. It's going to be 180. So we now have our 5-number summaries for both boys and girls. We are ready to draw. The question says, on the same number line, draw 2 box and whisker diagrams to illustrate girls' heights and boys' heights. So for boys, the numbers are 140, 154, 160, 180, and 180. And for girls, the 5-number summary is 150, 154, 160, 165, and what is the max value? It's 170. So I want you to start by drawing me a box and whisker plot for girls, but the problem is I don't have numbers here. So I have to put my own numbers in. So I'm going to look for the smallest value, which is 140, and the biggest value, which is 180. So I'm going to start with 140 here, and then I'm going to say, look, I'm not going to fill in every item, but I'm going to go 2, 4, 6, 8, 10. So that's 150. 2, 4, 6, 8, 10, 160. 2, 4, 6, 8, 10, 170. 2, 4, 6, 8, 10, 180. 6, 8, okay, 188. So I get my number line, so it covers this whole thing. I want you to draw the box and whisker plot for girls now. And I want you to say done in the chat when you are done. So this is 170. Draw me a box and whisker plot over that number line. And just say done when you are done. So just say done when you are done. I'm going to go from 154 to 165 and draw my box. What else has to go in there? I want you to think, what else has to go into this to make this a box and whisker plot? So I think I've done the 154, the 165. What I need to next do is the 160. And then my whisker goes up to 170 and down to 150. So this is the girls' box and whisker plot. I want you to now take the boys and draw the boys' box and whisker plot directly above the girls' one so that we get a comparison between the boys and the girls. So that is your next thing to do. I want you to draw it for me and then say done in the chat when you are done. What would you start with? I'm going to start with 154 and 180. So where's 154? 154 is there, but 180 is all the way up here. So the box looks huge. Look how big that box is. Now, the box represents the middle 50% of the data. So the middle 50% for boys is way more spread out than the middle 50% for girls. That's much more concentrated. The whisker goes down to 140. So the bottom 25% is also much more spread out for boys. And then the top, oh my gosh, there's no top whisker because the Q3 and the max value are the same, which is a bit weird, but it is true here. So we can compare here. It says, this is the box and whisker for boys, and this is the box and whisker for girls. And you can see how much easier it is. Oh, I've left something out. What have I left out for boys? Who can spot what I've left out for the boys' box and whisker plot? Who can spot what I've left out? Well done, Siamtanda. Yes, I've been a little bit hasty and left out the 160, which is here. So as we look at this, it says the final question here, use the 5-number summaries, the interquartile range, and the box and whisker to write down conclusions, 2 conclusions you can make about the heights of boys and girls. So this is a bit of an open-ended question. And there's a couple of different things you could say. I'm just going to show you some of the interpretations that I would think about. But there are a couple of ways, different facts you could use. I would say the middle 50% of the data for girls is much closer together. So if you look at this, what I'm saying is this is Q1, that's Q3. The middle 50% of the data for girls is spread out over that range. The middle 50% for boys is spread out over that range. Look at how much bigger the blue thing is than the smaller, than the yellow one. Another thing you could say is that the bottom 25% of data for boys is much, sorry for my writing, is much more spread out than for girls. And the way I would show you this is you can see the whisker here. This is the bottom 25% of data. Look how big that pink whisker is. If I now have a green whisker, look at how much smaller that is. So those are 2 possible observations you could make. There are a couple of other ones, but give me a thumbs up if you understood my 2 comments that I made there. Give me a thumbs down if you're like, what is this crazy person coloring in? Thanks, Dr. Bonga. Thanks, Kelebukile. Good to see those thumbs. Okay, thanks, Siamtanda. All right, everyone. Now, I think for today, that is enough.